I'm going to solve the equation tan theta equals 1. What I've drawn here is a unit circle with an angle theta that the red vector makes with the positive x direction. In this situation, the height of the arrowhead off the axis would be referred to as sine theta. And the base of this triangle would be called cos theta. That's how far to the right the arrowhead is from the origin. However, one way that we can draw the tangent of theta is we can extend our angled arrow until it intersects with a vertical line where the vertical line is tangent to the unit circle. And then what we can say is that this distance here is a visual drawing of the tan of the angle. It's a way of drawing a tangent using a unit circle. And we have also a couple more things that we could label here. Because this is a unit circle, the radius of it must be 1. And then this diagonal has a name as well. The diagonal must be the secant of theta, because we have the identity of 1 plus tan squared theta equals secant squared theta. This is a Pythagorean identity for angles. Now I'm going to try to solve the equation tan theta equals 1 by taking an arctan or inverse tan of both sides of the equation. I'll do this by writing tan inverse of tan theta equals tan inverse of 1. Now tan inverse is also written as arctan. The -1 there doesn't mean to raise it to a -1 power. It's just a notation for inverse trig functions. So these are actually just two ways of writing the same thing. Arctan and tan will cancel, so we'll get just theta equals arctan of 1. Now, like all the inverse trig functions, they have a limited range. The range of arctan can be drawn on the unit circle. It's only going to be angles from -90 to 90 degrees. Non-inclusive. So here's a -90 degree angle. Here's a 90 degree angle. Those technically won't be part of the range, because as you can see, if the angle was pointed directly up at 90 degrees, that could never intersect with this vertical line on the right. So the range of arctan theta will therefore be -90 to 90, but non-inclusive. In radians, that's -pi/2 to pi/2. All right, so we can just do this on calculator, the arctan of 1. You have to hit second and then the tan inverse there. And just make sure you're in the mode that you want. I'm going to switch to degree mode because I want to get a degree angle result here. And we'll do tan inverse of 1. It tells me 45 degrees is the answer to that. However, with this type of equation, we have to be aware of the fact that our range is limited. And so even though 45 degrees does work as a solution to this equation, so this length would be 1 if our theta was 45. But in addition to that, there could also be other angles which could work as well. If, for example, the red vector was not just a 45-degree angle, but if it had gone all the way around to be in 360 plus 45, if I was to plug in a theta of 405 degrees, that would also result in a true equation. Let's see if it would. The tan of 45 degrees, it's 1. And now let's try the tan of 405 degrees. It's also 1. And if we even go farther and try, let's say we go twice around the circle and then add another 45 degrees. That would be 765 degrees. It's also 1. Not only that, but you could also go in the reverse direction. If we were to go backward around the circle and come back here, that would be negative 360 plus 45. It's negative 315 degrees. That's also 1. So a lot of different possibilities are solutions to the equation. And, this would be 1 times 360 plus 45. This is 2 times 360 plus 45, and then negative 1 times 360 plus 45. Our solutions are therefore going to be n times 360 plus 45, where n is any integer. If we're putting this into radians, it would be n times 2 pi plus the radian equivalent of 45, which would be pi over 4. That's one possibility, but let's see if there are any other angles that would have a tangent of 1 as well. In the unit circle, when we're in quadrant 1, we're going to have a tan that's positive. If we're in quadrant 4, the tan of theta will be negative. So what happens in quadrants 2 and 3? Well, in quadrant 3, if we have an angle that's 180 degrees opposite of the 45, so let's say 180 plus 45, what is the tangent of that? What we're going to have in quadrant 3 is that our tan of theta will also be positive there. And in quadrant 2, tan is negative. So let's try plugging in a tangent of 180 plus 45. It's also 1. So what we're going to need for this is we're going to also need angles where we could have n times 360 plus 180 plus 45. So what it ends up being is that we can have any integer times 180 degrees plus 45 degrees, where n is any integer. This takes into account angles where we're in quadrant 1 or quadrant 3. So as far as the radian answer goes, it would look like this. So these answers here just don't include enough possibilities. Our final answer is going to be this.